limit x tends to 0. This is log b plus x minus log b minus x whole upon x. Now look carefully. In terms of log that we have formula in limits, this is limit x tending to 0, log 1 plus x whole over x. It should be in the form of 1 plus. To get that form, first of all, we'll have to take b common internally. So this will be limit x tends to 0, log, when we take b common, it will be 1 plus x upon b, right? Same way over here, b common, this will be 1 minus x upon b and whole upon x. So this will be limit x tends to 0, log b plus log 1 plus x upon b. Which result are we using? Log a into b is log a plus log b. Same thing over here, minus log b and minus log 1 minus x upon b and whole over x. Now this log b and this log b cancelled. Now we can distribute the limit. Limit x tending to 0, log 1 plus x upon b whole upon x minus limit x tending to 0, log 1 minus x upon b whole upon x. We have distributed the limit. जो भी plus के बाद है, the same thing should be there in the denominator. After plus, it is x upon b. So this will be, we'll multiply divided by 1 upon b. We can assume this as 1 plus minus x upon b. So this will be upon minus b into 1 upon minus 1 upon b. Right? Now this complete part will be limit x tending to 0, log 1 plus x upon x is 1. So this complete part will be 1 upon b into 1 plus 1 upon b, because minus minus will be plus, into 1. Result will be 2 upon. Is it clear? It is 1 plus x upon x. जो भी plus के बाद है वो upon में होना चाहिए. यहाँ पर 1 plus x cube है. So we'll be needing x cube to balance it. So we'll multiply and divide it by x cube. Now watch out carefully. This x square and this x cube cancelled. We will write it as limit x tending to 0, 10 5x upon x divided by limit x tending to 0, log 1 plus x cube upon x cube. Right? Here, the only additional thing that we need is 5. Now, 10 theta upon theta will be 1. So this will be just 5. And this will be 1. Result is what is? So we have written this minus 3 as minus 1, minus 1, minus 1. That is all about distribution of the limit. 1 upon 3 outside, limit x tending to 0, a to the power x minus 1 upon x, plus limit x tending to 0, b to the power x minus 1 upon x, plus limit x tending to 0, c to the power x minus 1 upon x. Is it clear? Clear to all? Now, what is ax minus 1 upon x? Log b. This will be log a plus log b plus log c. We can write it as log a, b, c. We can even write it as log a, b, c to the power 1 upon 3. When using the formula, a log b is actually equal to log b to the power a. Followed? Clear? Whenever it is a multi-definition function, or we need to check existence of the limit, that whether the limit is existing or not. In these two cases, we make the use of one-sided limits. One-sided limit is when we find it out only from the left-hand limit or the right. When we only find left-hand limit or right-hand limit. The representation of left-hand limit is x tending to a negative fx. And to evaluate it, we write it in terms of h as h tending to 0, f a minus h. Similarly, right hand limit is limit x tending to a positive fx, and to evaluate it, we write it as h tending to 0, f a plus h. For existence, the condition is left hand limit should be equal to the right. If they are not equal, the limit will not exist. That's the concept that we have done yesterday. Let me tell you a few examples, then I'll take up the problems from the exercise if you have any. Look. Example 5. This is limit x tends to 1 fx. We need to evaluate this, and the value of fx is given out to be 2x plus 3 when x is less than or equal to 0, and it is equal to 3 into x plus 1 if x is greater than 0. See, as stated in the explanation, if it's a multi-definition function, there are two definitions of fx given, and one thing more in this. Listen to it carefully. If the definition is given at the point at which we need to find out the limit, is it extending to 1 or extending to 0? Extending to 1. Now look, it is mandatory to make the use of one-sided limit if the definition which is given is also at that point where we need to find out the limit. जैसे यहाँ पर one-sided limit required नहीं है. Try to get my point. Not everything which is given in the book is right. In the solution, they are using the concept of LHL and RHL for this, which is not exactly required, and we need to understand this why. It is not just randomly कि जहां हमारा मन किया वहां पर हमने LHL RHL का यूज कर लिया, जहां मन किया वन साइड लिमिट्स यूज करी, जहां मन किया डायरेक्टली लिमिट फाइंड कर ली. देयर हैज टू बी अ लॉजिक. यहाँ पर डेफिनेशन तो हमें 0 के अकॉर्डिंगली गिवन है, बट लिमिट हमें 1 पर फाइंड करनी है. अगर हमें लिमिट 0 पर फाइंड करनी होती और डेफिनेशन भी 0 के अकॉर्डिंगली गिवन है, then it would be mandatory to make the use of one-sided limit. इसका सिंपल सा लॉजिक ये है, जब हम 1 पर फाइंड करेंगे, चाहे हम 1 प्लस h करें, अगर हम 1 प्लस h करेंगे तो भी ग्रेटर देन 0 आएगा, और अगर 1 माइनस h करेंगे तो भी ग्रेटर देन 0 आएगा. दैट मींस दोनों केसेस में, चाहे वो 1 प्लस h हो या 1 माइनस h हो, एक ही डेफिनेशन यूज हो. So that is the reason we do not need the concept of one-sided limits over here. I hope I have made this point clear. Just to sum this up, जिस पॉइंट के अकॉर्डिंगली डेफिनेशन गिवन है, उसी पॉइंट पर अगर हमें लिमिट फाइंड करनी है, then it is mandatory to make the use of one-sided limit. Otherwise, you can find it. जैसे हम यहाँ पर फाइंड करने वाले, because we need to find out limit x tending to 1 fx. Now, for 1, we'll be using the second definition because 1 is greater than 0. So, this will be limit x tending to 1, 3 into x plus 1. Straight away, because the form is not 0 upon 0, we can directly put up the value of the limit. So, this will be 3 into 1 plus 1, 3 into 2 equal to 6. This is the value of the limit, as simple as this. Unlike the example that they have done, they are solving left hand limit and right hand limit, which is not exactly required. यहाँ पर हमें फंक्शन की डेफिनेशन 1 के अकॉर्डिंगली गिवन है और लिमिट भी हमें 1 पर फाइंड करनी है. सो इट विल बी मैंडेटरी to make the use of LHL RHL. So first of all, left hand limit. Now left hand limit will be x tending to 1 negative fx. This will take the form h tending to 0 f1 minus h. 1 में से कोई वैल्यू सब्ट्रैक्ट हो रही है, will it be less than 1 or more than 1? Less than 1. Less than 1, first definition. When I say first definition, I mean that in the first definition, in place of x, we need to write this value. So in place of x, 1 minus h of whole square minus 1. Is it clear? Some people unnecessarily make the things complicated. Like, जैसे यहाँ पर form 0/0 नहीं है, so we do not need to open this bracket. If the form is not 0/0, straight away you can put up the value of the limit. So in place of h, we can write 0. So this will be 1 minus 0 of whole square minus 1. Complete part will be 0. Left hand limit. Wait. Now right hand limit. Right hand limit will be x tending to 1 positive fx. This will be limit h tending to 0 f1 plus h. A positive value is being added to 1. So greater than 1. Greater than 1, first definition. Second definition. Thank God you people are awake. H tending to 0. So this will be minus 1 plus h of whole square minus 1. Do we need to open this bracket? Then what will we do? Put the value of the limit. So in place of h, we will write 0. So this will be minus 1 plus 0 of whole square minus 1. So this will be minus 2. What do we conclude? LHL is not equal to RHL. Therefore, limit x tending to 1 fx does not exist. Am I clear with that? Followed?